Welcome once again. Now we have a panel discussion. So this discussion is going to be on continuous flight auger piles, CFA piles, a system changeover, and risk assessment and mitigation. The moderator for this discussion is Mr. Madan Kumar Annam. He is Head of Engineering, Keller India. I take this opportunity to welcome Madan and introduce him. Madan Kumar is a practicing geotechnical engineer having 25 years of experience in analysis, design, and execution of foundations for infrastructure projects. He is presently responsible for engineering in Keller India. He has handled several complex geotechnical engineering challenges throughout his career. His area of interest includes construction of heavy foundation, especially board piles, diaphragm walls, deep excavations. Apart from this description, I know Madan Kumar since 1999. We worked together since 99. We are all still in contact, and it gives me great pleasure to be with him and he being the moderator for this discussion. Welcome, Madan.
Thank you, Dr. Kumar. Thank you very much. It's a great opportunity for me sitting next to you. Okay, now I'll take over. So being a moderator, and this particular topic is very interesting for everyone. So dear delegates, welcome. So we are going to have a panel discussion on CFA piles. So we have three experts from industry, Mr. V.K. Panwar from Engineers India Limited, so Mr. Andres from Keller, Florida, Mr. Franz Warner, so he is from Bauer Maschinen, Germany. So we have three experts with us now. So what we are going to do, so I'm going to make this presentation. We made a structure. So initially, we are going to make an introduction. So the introduction will be like very simple inputs. What is CFA pile? How it goes? It's very like a kindergarten information. Then we take some inputs from owner or consultant's view from Mr. V.K. Panwar. And then we can ask Mr. Franz Werner to speak about equipment and manufacturer's views. Then we can have Mr. Andres. So he will deliver three interesting case studies at the end of the session. And later we will have question and answers. Okay. So overview of CFA piles. So let us know what is a CFA pile. CFA pile is nothing but a board pile, but it's a change of installation methodology. Okay. So installation methodology, like, so we simply drill through soil and then extract the soil. While extracting the soil, so concrete will be poured. Later reinforcement cage will be inserted. So as simple as such, but it's so critical. We will go through the next slides how it's going to work. So we have a simple video here. So it's like 2 minutes video. You will understand how CFA piles get installed.
Continuous flight auger piling is a fast and economical piling method, ideally suited to wet or granular ground conditions, which otherwise would require the use of temporary casings to support the ground. Pile depths of up to 32 meters depth can be achieved using powerful crawler-mounted drill rigs. A CFA pile is constructed by rotating a full-length auger into the ground to the required depth. Auger diameters from 450 millimeters to 1200 millimeters are common. The auger has a hollow stem which is connected by a flexible hose to a concrete pump. The hose and stem are charged with concrete before drilling commences. Once the auger reaches the required depth, concrete pressure dislodges a temporary cap at the base of the hollow stem, and concrete is pumped under pressure into the ground while the auger is withdrawn, carrying the excavated soil upwards. Different designs of auger cleaner require the auger to either be stationary during extraction or to be slowly rotated in the same direction as used when drilling. Soil is flighted up the auger and is removed by an auger cleaner just above the ground surface. Once the tip of the auger returns to ground level, concrete pumping ceases. The accumulated soil is then cleared away from the pile head. Then a prefabricated reinforcement cage is plunged into the pile while the concrete remains fluid. Special attention to the concrete mix design is required to maintain its workability and to ensure that the reinforcement cage can be inserted to the required depth. The pile concrete is allowed to set before nearby piles are constructed. Piling contractors. Think safe, work safe, home safe.
Madan sir, you are mute. You can unmute yourself.
So we can use the CFA piles, anything you can use for board piles, like supports for structures, so retention system or any other infrastructure projects. So we can see the reality executed CFA pile system in the next slide. So here we can see the supporting system for foundation piles, a retention system, and circular shafts, second board piles, soldier piles. So all these works are executed using CFA pile. Now coming to equipment requirements. So what are the equipment requirements? So they are simple hydraulic drilling rig, but it has to have a CFA kit. So you can see right side image. So that's a large machine, so which has an auger. So but to turn that auger, so we have to have high torque. So the CFA kit can be attached to hydraulic drilling rig, so which is having high torque and which need high mass as well as pull capacity. Okay. And further, so high concrete pump is required for pumping concrete, and real-time monitoring is required. Okay. So rig power is crucial for successful implementation of CFA pile. So a typical site setup, you can see here, a CFA rig supporting with an excavator and supporting crane and a concrete pump. So these are typical site setup. Having site is very clean when compared to board piling site. So what are the advantages or any other challenges? So since we don't use drilling fluid or casing, so CFA pile installation is very faster, is almost like 3 times faster than board piles if we compare with a similar diameter. Since there is no bentonite or casings, so we can expect higher geotechnical capacity. But sometimes there are challenges. So there may be difficult in drilling through hard soils, or maybe sometimes it is difficult to sucketing into rock. Also, heavy reinforcement cage lowering may also sometimes be difficult. So, but we can overcome all these challenges when we have sufficient equipment and sufficient technology and quality control in our hand. Okay. So this slide illustrates how CFA pile capacity we can see. So you can see driven pile capacity like a dotted line extreme and board pile to the left side. So CFA pile capacity can be somewhere in between board pile as well as driven pile. So we can see some improvement when compared to board pile. So need of hour in India. So in India, what happened nowadays? So many projects, and time pressure is very high, and high demand for fastest delivery, and quality control is getting so much crucial nowadays. So clients are pushing contractors to complete the projects so quick. So therefore, end of the day, contractors are mobilizing many resources like piling rigs and associated equipment, which leads high costs in delivering the project. So how can we optimize the cost of the construction? So DFI of India has come up with a solution that we can bring the new technology which is being utilized worldwide. Like CFA is being utilized, almost like 25% of files are being installed across the world. So why can't we bring this technology to India? So this initiation taken by DFI India, and they started how can we start this particular technology, and what is the first step? Okay. So what DFI did, so with the collaboration with the local specialist contractors as well as supporters. So one of the project site, they are located in North India. So where the next slide please. So where we try to install few trial piles. The first two trial piles, like how CFA pile can be installed, and the last 6 files, they are real test files. So out of these six files, 2 files are compression and 2 files dedicated for lateral and 2 files are for uplift. So with the help of support DFI of India, they completed all these files and tested successfully. From that experience and the experience they have taken from the international specialists, and DFI of India have come up with guidelines. So design and construction guidelines for installation of CFA pile. So these guidelines is prepared by DFI of India and then issued to Bureau of Indian Standards recently, and we are expecting some response from them for implementability. Okay. So now that is the background of CFA introduction and what DFI did as of now. So with this background, what we are going to do, so we want to see how owners like consultants or government owners or private owners, what they expect from contractors when a new technology being introduced in India. So that we can hear from Mr. V.K. Panwar. And secondly, so we can hear from Mr. Franz Warner. So what are the equipment are required? So we have a lot of equipment in India. So how we can utilize the existing equipment to make use with the CFA kits. So what are the facilities? So he will explain equipment manufacturer point of view, and at last we can see how successfully CFA files are executed at complicated area. So 3 case studies will be given by Mr. Andres. And after hearing this, then we can have question and answer session. So now I can invite Mr. Panwar.
Sir, as Mr. Vijay Kumar Panwar is facing some audio issues, I request yourself to go through his points, please.
Okay. So can you please run through slides? Yeah. So I can introduce Mr. Panwar. So Mr. Panwar is Senior General Manager of Engineers India Limited. He is very well-known person in India. Mr. Panwar is heading Onshore Geotechnical Group of Engineers India Limited. His areas of specialization includes all activities related to geotechnical engineering works, foundation design, ground improvement, slope stabilization, earth dams, and etc. He is responsible for providing complete geotechnical management for refinery and petrochemical, so non-ferrous, metallurgical, cross-country pipeline projects, which includes designing, detail engineering, coordination, preparation of front-end engineering documents. So Mr. Panwar is specialized in all documents, in all departments of large hydrocarbon projects, starting from tendering to execution. He is a committee member of Bureau of Indian Standards and also executive committee member of DFI of India. So, this presentation Mr. Panwar he made, he tried to make that what are the ways a government looks or a owner looks. So when a new product comes to India. So I will go through his presentation, and I can give you a few tips. I can read, maybe you also can read, but some of the outcomes I can explain. So here in the first slide, so existing practices of contractor point of view or consultant point of view. So there are two types of contracts in government or any public sector or private sector. So they are item rate tenders or lump sum turnkey projects. Okay, next slide please. So the process involves invitation of bid and the bidder's qualification criteria. So this is the major principle that any government or private agencies they follow. Okay. So Mr. Panwar joined now. I think he can explain now. Mr. Panwar.
Hello. Am I audible?
Yes, sir. Please.
I'm sorry, because of some technical issues, my audio is not working.
Yeah. Can you speak or can I?
Hello.
Yeah, please, sir. Okay, so he has some audio issue. So I will continue. I will try to brief what is there in the slide. So basically, we are in his slides. He is trying to talk qualification criteria. That is the major issue, and in invitation for bidding.
Sir.
Please. So let me explain. If anything is there, you can come in between.
Mr. Madan, you can continue with his presentation. You can just. His voice is not coming.
Okay. Yeah. So normally, so the general process. So when invitation for bidding, so they include like bill of quantity basis. In that pile diameter or length and capacity, everything is specified. Okay. So a contractor is supposed to bid for that. Okay. Next slide, please. Okay. So once a contractor got qualified, then he has to execute piles as per the construction drawing. Is issued construction drawings. So that is what the first process bidding qualification, and it is how it goes. Okay. The next step. Okay. Continue. Yeah. So there is another mode. It is the lump sum turnkey mode. So in this case, execution of piling works is carried out by agency appointed by the LSTK contractor, the main contractor. Okay. However, some basic requirements such as type of pile as specified in the contract document, which cannot be changed. So there are some rules already made in the contract document, and the main contractor, he cannot overcome the specification specified in the main document. So that is what one of the important statement which is made in this LSTK mode. Okay, next slide, please. Yeah. So here there is an encouragement. So there are so many hurdles are there to encourage new technologies in India. So, but there is an encouragement statements here. So since non-availability of design codes or guidelines or experience in India, so here I can see that government or consultants, they expect a lot of database. So sufficient database or case histories need to be developed. So I can understand which are not available as of now. Okay. So that is what the conclusion I can see here. So more trials need to be conducted across India, and then database to be developed, and then based on that, contractors can propose an alternative solution, and the consultants may accept that. In the meantime, contractors may approach private, civil or piling contractors, so they also can do on their own instead of going to government projects. So here there are two different aspects. One is government, other one is private. So private agent contractors, private owners, we can go and approach for implementation of new technology, whereas government, we can produce a lot of data. So this is the way forward Mr. Panwar is suggesting. So any next slide? Yeah. So once we have good data and the draft code is approved by BIS, Bureau of Indian Standard, so then I think it will be there is a clear route for entering into Indian market. The CFA system can enter into Indian market. I think that I could see that conclusion in this slide. Next one, next slide. Okay. So from Mr. Panwar's presentation, I could see that he tried to highlight what are the specific issues in public sector and what are the freedom in private sectors, and then how to overcome these simple hurdles, and he has given a way forward. I think this is a good sign. Thank you, Mr. Panwar. So we got a clear message. I think our audience also got a clear message from your presentation. So thank you very much. So next, what we do, we will invite Mr. Frank Werner. So previous session, he delivered a keynote lecture, paper presentation he made. So I no need to introduce again. So Mr. Frank Werner, so he is an expert in almost like 25 years in his pocket, and he handled several tough jobs, and he was leading a development department for diaphragm walls and cutoff walls, development of equipment. I think we have seen his introduction previously. So he is a DFI member for a soil mixing committee, and he is a board member of DFI Europe and member of the board of trustees. So Mr. Frank Werner, so please let us know the CFA piles and equipment manufacturer perspective. Please give us.
CFA continuous flight auger. Some thoughts from an equipment manufacturer perspective. So today I want to have a look at two major points. The one is equipment and safety, and the second one is quality assurance. And with equipment and safety, I want to focus on Kelly extension and auger cleaner. But to get an overview of what we need if we want to convert any kind of drill rig into a CFA equipment, of course, let's say we have to modify maybe a little bit the rotary drive, that we have a flushing head, let's say for the concrete. So we need concrete line. And of course, you need this CFA auger and a CFA starter. And as said, two major points I want to talk about is the auger cleaner, because this is a big safety feature and also act as a guidance. And what we see here is a so-called Kelly extension, because this is an option to extend the drilling depths. So what does it mean? If we have a look to this equipment, usually, let's say the drilling depth is somehow determined by the stroke of the rotary head. But with certain capabilities of adding a so-called Kelly extension or mast extension, you can increase the depth capability. This is quite a nice feature, yes, but you have to understand and respect where are the limits of using this kind of extension. Because at that time where you pass with this extension into the ground, there is no more, say, soil transport upwards, because there is no flight again anymore, and the soil must be stable to avoid a collapse. So say that it's a nice feature, but you have to respect the limits. But with this, you can achieve bigger depths with smaller size of equipment. Second, the auger cleaner. If you have a look at this left picture, this is a situation we definitely don't like and don't want to see. Because if there is the spoil on the auger dropping down from height, this can cause injuries for the personnel on the job site. So in principle, it shouldn't be allowed to work without an auger cleaner. Auger cleaner can be seen in various types. Here we display two, the so-called roller auger cleaner or a flap auger cleaner. So these are two options depending on the soil conditions. There are more types available from other companies as well. To see how they are working, here we can see the video, a little bit difficult with the performance of the internet. Here you can see the roller cleaner cleaning the auger from the soil during the extraction process so that there is no spoil remaining which could drop down. On the right hand side, after a little bit movement of the sledge, you will see as well how the auger cleaner cleans the auger during the extraction process. So this is quite an essential topic on that procedure in terms of equipment. Second, I want to talk about quality assurance and quality control in terms of materials and in terms of the operating of the equipment. Of course, materials is not necessarily a part of for the equipment, but to round it up, I want to talk about this as well. So concrete receipt and quality is quite essential. So we heard earlier today already that we need to take care about the consistency, the stability. We have maybe to limit also the concrete aggregate size compared to standard drill piles to ensure that we have a smooth concrete to ensure the installation of the reinforcement cage. Also, the reinforcement cage design needs maybe a little bit more, let's say, input, more quality in terms of welding. Maybe we should consider a tapered shape of the reinforcement cage to ensure a proper and smooth installation. Coming back to the equipment. So to operate the equipment, you may need some assistance systems to release the operator and to ensure proper and constant pile quality. We heard this already again before. And of course, let's say this is also used with all the data to give a reasonable report and to show what has been done. For CFA in specific, there is one so-called drilling assistance system, which helps the operator to keep the filling rate at the same level at all times. So there are some input parameters to take in: crowd speed, force, RPM, and auger dimensions. And why do we want to have this? Not only to release the operator, but also to get a good quality. And here we are coming to some features we saw this morning or earlier today. It was my morning, your afternoon already. So what we want to have and see is this first case. We want to have an ideal ratio of crowd and rotation speed, that only the soil is coming up from the drill head to stabilize the borehole, so that no lateral transport take place. What we want to avoid is, for instance, this second case, where high rotation and low crowd speed leads to an excessive excavation with the loosening of the surrounding soil. So this means you have, let's say, overflighting, you have more spoil, you may have more concrete requirements, and you have maybe a lower pile performance. This is something we want to avoid. And third, we also want to avoid a so-called corkscrew effect. That means we have a high crowd speed with low rotation, and this leads to, let's say, high tensions on the crowd system, which may cause damages to the equipment. So this is what we want to see, the first case, and this drilling assistant helps the operator to achieve this. After reaching the final depths, of course, we need to start concreting. And also there we want to ensure the, let's say, constant concrete flow. We want to have constant concrete quality. We want to have a defined concrete overconsumption to have a repeatable concrete and repeatable pile installation. So therefore we have a so-called concreting systems where with all the features, especially concrete pressure and concrete volume. The concreting process starts in automatic mode as soon as the operator hits the start button, so that you just need to control this concreting process, that the flow and the pressure of the concrete is fine. And this will lead to a repeatable installation of the pile. Saying that, we have this equipment and some specific features, as we said, the concrete line with the flow control and the pressure control. And to round this up, everything is shown to the operator in real time, that he can control the system. And of course, these data are stored and are available for getting a nice protocol and report for what we've done for each single pile. So this is how to operate, to assist and to manage this system. Regarding equipment in India, there was a huge discussion on that. So actually, there are some drill rigs of the power fleet which are actually prepared for Kelly drilling in various types. So here we can see some smaller ones where, for instance, CFA drilling would be possible, starting from a depth of 13 meters up to 25 meters in depth, depending on the size and depending on, let's say, the attachment, whether with or without Kelly extension. And there are bigger ones also in India with a depth capability of up to 31 meters. But it must be said, these are in principle prepared, but of course, there is no CFA kit actually in India. That means to get this system started, there is some investment required. For whoever wants to start it, we need an auger extension, we need an auger, we need an auger cleaner, we need some software update, but then it is possible to start drilling CFA with such kind of rigs. And I think this is the same situation for all others. So far, the manufacturer's view. Thanks for your attention.
Thanks, Mr. Franz Werner. So you've given us a very good insight on availability of equipment, safety, and modern tooling, materials, and their instrumentation. And also you explained us Kelly extensions and auger cleaner method, and focusing on QAQC on materials, and very interesting data acquisition systems and how to monitor. And Kelly synchronizations with Kelly and kit synchronization for power rigs. So you explained very nicely, and really happy to see the summary. Thank you very much. So now I have pleasure to introduce my colleague, so Andres. So he is sitting now other part of the world, Florida. So Andres is a CFA man in Keller. So he's a global product leader, and he is vice president in Keller, Florida. So, and Mr. Andres is global product leader and vice president for Keller, Florida. He has more than 1,200 projects in his credit and 25 years of design and build experience. His completed projects included auger and displacement piling, tangent bearing elements, vibro compaction, excavation shoring, and bottom plugs across the nation. So in 2020, HJ Foundations and 7 others have joined together and rebranded to Keller North America. So in 2011, Andres was named ASE Miami-Dade Engineer. In 2019, Andres was awarded the ASE National Roebling Award. Andres received his bachelor's degree in civil engineering from Los Angeles University, Colombia, and his master's degree in civil engineering from Florida International University. So Mr. Andres, floor is yours.
Thank you, madam. Thank you very much, and thank you for having me here. So we're going to be talking about some case histories and going through kind of the products, how can they develop an industry and help out make cost-effective foundations. We're going to talk about a residential project and how that changed the panorama of a city, a transportation bridge project, and some use of advanced technology on the CFA piling. First, the residential project. It is a job called in downtown Miami. It's the Met project. It began, as you can see on the pictures, being 3 large towers. At that time, the capacity of the piling system was meeting about 100 feet down, about 30 meters. And most people thought it was going to be a board pile solution. The cost of the foundation and the time to install it was getting a little bit difficult to perform. So through those foundation alternatives, they began setting up the 2 different options. One of them in board piling, about 1.8 meter piles, diameter board piles, and getting about 1,800 to 3,000 tons capacities, right? With a tension capacity of about half of that, of 800 tons. And even though it resulted in a few shafts, 124 shafts, the estimated construction time was 250 rig days, or calendar days, depending how you run construction. At that point, a subcontractor Ketter came in and said, well, we believe we can change to CFA and probably save some time or some cost on the construction. Sometimes the cost per se may be similar, but the savings on time can be significant on economic savings. So as you can see in the slide, we began proposing, of course, 914 millimeters, which here is a 36-inch diameter element. And we had to see how deep the pile need to go to support a compression capacity of 1,200 tons and a tension of 400 for the initial design. It resulted in almost twice the amount of elements, but we believe that the construction duration was going to be lower than that. The owner came back and requested a robust kind of test program to see how to prove the system. And so it was developed to see if the cap needed to change in the dimension. So this is one of the foundation mats on the bottom of this building. The red circles are the original board piles. And then the black little circles are the proposed CFA replacement for this specific project. More or less at the beginning, you could see it was like a 2.5 to 1. And depending on the areas and the needs for the project. When reviewed the design at that point and estimated the project and did initial test trials, we realized that the schedule could be as low as 70 rig days instead of the 250 rig days for the board piles. The installation of board piles in a budgie little holes kind of limestone that we have in the area resulted in a high need for casing and polymers and bentonite at that time frame that will increase the time duration for such foundation. With that, then the test pile specification that was brought by Langen Engineering and the different soils, as you can see them on the screen, we have a more or less 7 to 8 meter thick limestone, followed by about same depth of sand, about another 15 to 12 meters of sandstone, and then finally the bearing layer down here, which would be about 30 meters down in that behalf. So they request us to install a CFA with a OSIL or a embedded hydraulic jack into it. We had to have a full strain gauge system at different elevations to measure that friction of the different soils, as the geotechnical knowledge for those soils were not the same as before. After that, we had to put a simulation pile in the ground to guarantee that the jack will go down, and a couple of other piles on the same day to guarantee that the system could install 4 to 5 piles as was promised. One of the important ones, of course, was the communication assessment pile. That was how close we could install one pile to another without getting the new pile that is being drilled pulling the grout or concrete out of the previous one. So that what had to be done in the same day, pretty close, and verify those conditions. All of them, as you can see, about 36 meters to 38 meters deep elements, verifying the ability to actually reach such depths. A hanging system was brought at that point. You can see the auger on the back with a lead system, as the depth of the pile was deeper than the fixed mass rigs could do at that point. The pile was drilled, a double jack system, as you heard Mr. Marinucci talk about on some of the board piles. So similar, we're putting the Ostenberg cells or hydraulic embedded jack cells into the pile, and depending how you run them, if you run one open and the other one closed, you will be able to get the full friction just in the intermediate portion of it without affecting the top or bottom, and get that friction capacity on that area. When you alternate both or close both jacks simultaneously, then you can get the full capacity of the element. Big element for these mega piles end up being that you end up using, of course, a sizable amount of reinforcing, and instead of using half a truck or a quarter of a truck in the sense of a couple of cubic meters, you end up using several cubic meters, up to 5 trucks per each one of the piles. So coordination of delivery of that mix, and as Franz Warner was talking, the mix has to be designed properly to guarantee fluidity for a long period of time in these kind of piles, kind of an hour or 45 minutes, so it's liquid enough to be able to insert the cage after the process. With that, the final design was achieved. As we can see in the screen, some of the elements were actually discounted, so we had less elements at the end that we thought about because the piles were reach a higher capacity than before. On this specific project, a total test load of 10,000 kips, 5,000 tons was achieved, and it certified the pile for at least 1,200 tons as per the code's discounts. More importantly, the proposal back at that point saved a direct $3.5 million to the developer, and in addition to that, it saved 180 rig days. In the cost of construction on North America, some of these buildings are paying $30,000 to $50,000 a day on interest for the duration of the construction, financial costs. So if you end up saving 6 months of construction, the amount of savings on the financial side way outperform any other savings that cannot be brought in the other direction. So savings can be brought in the two pictures. One of them in the kind of direct savings for the proposal, the other one in the time that it takes to install. There's finally some of the production happening, full length cages, that kind of 35 meters or so being installed to the ground to achieve all the tension capacity. You can imagine that when you install a pile close to that one, the next pile is going to be about 6 meters away. The next pile will be 6 meters away. The next pile will be 6 meters away. So in a single day, there is a lot of area that is being covered, and therefore it's difficult to add more than one crane rig on a kind of determined area, about 4,000 square feet. Final product, when the job is excavated to put the cap on top, piles are being cut by hand and rebar being exposed, depicting a really nice round pile to continue in construction. When we do this sizable amount of projects, the really important task is to realize that everybody is ready for them. The material supplier has to be ready to deliver all that material, but also the testing agency will have to have the right setup to collect all those samples that are required per specifications. Now, after we began doing jobs like that, you can see that back in the 1990s, some of the CFA was shorter piles. You can see here about a 15-meter to 12-meter pile being installed pretty close to the Freedom Tower. It's a famous structure in Miami, the Freedom Tower. About 10 years later, the CFA has grown to do 900 millimeters and about 30 meters deep elements you can see close to the Freedom Tower, and it kept advancing. And the reason for that was because we could bring savings to the developers and the structures. This is 10-year span. The next picture is going to be 4 years after this picture you see on the right side. And it was the explosion of construction in a city. So you can see the same Freedom Tower there with all the new towers being installed, with 90% of those buildings being done in CFA, really tall structures, as the savings of the time was beginning to be available, the economics of the construction in those areas. So when you introduce a new system to a city, you can actually transform the city, because you become a lot more cost effective for investors to come along and do so. As modern job site, this time in Tampa, just going through it. So it's not all everything has to be massive and mega piles in that we have. This one is a 21-story, some sandy soils on top of limestone conditions, pretty hard 50 below refusal limestone. The job was done initially in board piles. A CFA option was proposed to be done to kind of similar depths with different load capacities. The load test again was performed, measuring the settlement of the pile first to design load, and then to run an overload capacity to see what is the maximum that pile could hold. We reach out the maximum capacity of the jack and the frame before we can fail the pile. The CFA option brought $400,000 of savings plus 1 month of schedule. This is the tension graph of the pile, depicting quite a nice kind of a curve following pretty good theory with it. Moving into the realm of the bridges and the public transportation work, we're having this bridge in the Florida DOT, Department of Transportation, which is the first bridge that is done in CFA in the last 40 years. Pretty nice arachnic spider kind of form, as you can see, with a lot of others kind of viaducts coming into play. I cannot show a lot of the slides on this project that is going on, but the interesting fact of it is that a lot of testing was being kind of chosen to prove it in the different places of the city. Now we have a more tighter conditions to install these elements, with the specific areas that are within houses and different streets, moving equipment, and then the spider form signature bridge on the end. One of the main things that they requested was to do a load test and prove that we could drill through kind of some decent, medium, dense limestone and some sandy soils. The original design was in 760 millimeter squared precast piles, about 23 meters long, and they were trying to achieve 900 and 600 ton capacities in the different areas. The vibrations that I brought to the neighborhood was not convenient, and some of the loading was not achieved in certain specific areas, as the precast pile needed to pre-drill all the limestone and then just get their end bearing capacity. Because of the friction capacity and the vibration issues, a diameter of 914 millimeter piles and 762. And the reason for those strange millimeters is because that is the literally translation move from 36 or 30-inch piles here in North America. Those elements there were kind of tested with a really stringent amount of specifications that you can see and read after in the presentation. So some of the resistance factors were defined, some formulas were kind of defined to see which ones were going to be acceptable through which kind of specifications, in this case the highway administration specs. More importantly, 4 thermal wires were going to be attached to every pile to verify if the pile had continuity and it was continuous enough to the bottom and the cage was reaching the bottom as designed. Testing with some 5% of the piles tested in dynamic means. We can see that 2 different rigs installing the piles in some of the areas close to all the bridges and not kind of having vibrations. We had a fixed mast equipment, as kind of portrayed by Franz Warner, drilling down to the maximum capacity, installing their piles. Another one is a fixed mast, because it's attached on the top, lattice boom system to do the 136 or so 38 meter piles to 40-meter piles on the Spider, so-called signature bridge project. You can see the spacers in different terms and a full-length cage to be installed in such elements. It's not typical to go that deep around the globe, but it can be done if you have the right mix design, the right procedures. With that, you can see a center pier. A couple of the legs are going to be supporting the spans, so some of the project is going to be installed in a couple of phases. Install one phase, followed by the second phase when they move the bridge around and keep installing and moving forward. Some of the piles on the viaduct resulted so close to the upper bridge that we had to install batter piles. That is when you take the auger and incline it to put an inclined pile and be able to avoid the upper deck, and in addition get the right location for those piles and achieving the capacities. All the calculations were done to verify that by putting that pile and the opposite pile in the other direction was going to have stable kind of caps, similar to what is done in some precast piles. Large equipment being done. One of the reasons that it was chosen to do so is because all these structures that we can see surrounding it, all these buildings that you can see besides this one here, but all the other ones are installed in CFA piles, including across the Science Museum and the Performing Arts. So there was a lot of confidence that that job could be done, as all the surrounding structures had been done before in CFA. They have excavated the caps, one of the caps, began to cut the piles, expose the piles into location, and be able to show kind of the progress in that. At this point in time, we understand we are more than 2 months ahead of schedule for their original schedule for precast piles and board piles. We'll finish now with a little talk about the use of advanced technology and instrumentation on the projects. So as Franz Warner talked, there's a lot of new technology driven in the computerized systems to be inside a cab for the operator to be watching what he's doing. There are different brands. There's a Bauer, there's Jan Lutz. Keller has its own system and always also uses the available ones on the market. They do have, as we were talking about, a volume and pressure gauges to verify the volumes and pressure that's being used. There's some depth gauges or transducer to verify how deep you're getting in the pile. And with that instrumentation, you can also get a record that you can later on go back and print out or submit to your client. It provides all the graphs to be able to show how much grout factor or concrete factor did you use on your project by strokes or by flow. What was the grout pressure at every time during pumping? Were you lifting continuously? You heard Franz Warner saying that speed has to be controlled. So are you pulling out in a consistent way to produce a good pile as you're pumping? And then depending of when you're drilling, can you compare the drilling records to the soil reports to show this seems to be a hard layer, another hard layer, another hard layer, and can be compared to the soil report and the borings to check out that they have the same elevations that were kind of anticipated. In addition to the monitoring of the drilling, strain gauges can be used by installing kind of different kind of brands into the pile attached to the rebar. They can be plenty of them prepared. Those are, you can see here, sister bars. You can have some geocon models. You can have kind of geo instruments models. There are many different models that we have. The important thing for those is when you install them, when you run your load test, you can analyze how much load did you put on top of your pile, how much load was reaching some specific layer that you're concerned about to see if they can hold the load. Or you could install a longer pile, and by instrumenting the pile, you could verify that the pile could stop shorter as you have already achieved all the capacity you were looking for instead of going the full depth that theoretically was assigned. So the owner can have a budget for the piles as designed, and he could have some savings after load testing the piles if the piles could be kind of shortened, proven by load test. There's also the PAT test. On the PAT testing, you end up getting a hammer, hit the top of the pile, it creates a wave of transmission through it. It's important to know that when you install these kind of elements and systems, it may create, if you have a hard layer over a soft layer over a hard layer, you may have a bulge. This is not to scale, but just to show the process that you can have a bulge, and you insert the cage. This is not bad. You are going to have a little bit more volume, but it's not bad. So having a signal saying that there's something there, it has to be verified with the soil report and the pumping records. If you have a soft layer, this is not a bad item. Now, if your cage was installed with no issues, then you prove that the shaft is open with no concerns. So the challenging thing will be if you end up having is a necking condition where you have a less diameter than intended. Finally, because of the thermal wires development, and this is our old pictures, the new sensors have evolved and get better. Cable sensors are attached to the rebar. At that point, a test was done a couple of years ago. You can see by the picture, it's a couple of years old. We end up installing some sand bags to that cage to see if the thermal wires could detect the lack of concrete cement grout in that area. And as you can see in the graph, when the model was done properly, then you can certify that if you have some less or not issues on some elevations, but also importantly is that the thermal wires is actually showing that the cage has reached the bottom, because it's the only way they can reach, they can attain a signal at the bottom is if the cage and the sensors got to the bottom, and if the pilot continues in that behave. It has to be modeled properly because changes in soils can change the algorithm. If you have hard soils over soft soils or backwards, then the algorithm can get confused by having a larger diameter on the top on the soft soils with a tighter diameter on the bottom on the hard soils. That change could be less than 1% of the diameter when you're pumping your pile. I really thank you for the time to be with us and open for questions.
Thank you, Mr. Andres. So you've given us very interesting case histories, 3 case histories highlighting successful deployment of the technique, private and public sectors. So one is a residential project, what you said. So it has covered, like initially it was proposed with the board pile, and we come up with the CFA alternative proposal. So you could able to make 250 rig days to 90 rig days. Is like a solid saving to client. The other one, the next interesting is public sector, a bridge construction. So conforming design was like precast or board piling, but it couldn't achieve the pile capacities, and alternative solution was CFA. So, and we could see the difficulties in execution. So it's an interesting job. And third one is using of advanced technologies. So very interesting. So thank you very much, Mr. Andres. So we have now a question and answers session. So a few questions are lined up here. So I will read questions from audience. So here we have the first question from Mr. Sunil Basarkar. So he is trying to ask, this is like urgency, now need of CFA in India. So why can't in the next 1 year time, while BAS getting approved, means BAS gives the confirmation, why can't the government agencies, so why can't they write their technical spec by asking main contractors to use CFA as an alternative? So I think Mr. Basarkar, I think this question is more related to our Panwar Saab, but since he is not there, we will definitely inform him. But your question is very valid, and we will inform him, and we will definitely see the success. So the next question I have from Mr. Mohan Ramanathan. So this is to Mr. French Werner. So this is equipment related point of view. So when using a normal hydraulic rig, with a CFA kit, will there be a stability problem, especially when pulling out the long auger? Do you suggest any special safety measures for ground compaction?
So first of all, the question is, what is a normal drilling rig? But in principle, all the drilling rig manufacturers, whenever they have their CFA attachment in place, they made, or they have to make a stability calculation according to the required standards. And this somehow covers, let's say, that we have to deal with specific retraction forces. So usually it shouldn't be a problem with the stability as long as a working platform is okay. This is maybe another issue, needs to be discussed in general, but according to the stability of the equipment, there is no problem expected.
Thank you very much. So we have one more question here. So one Mr. P.N. Ravi, he sent one question. Bring this question to Mr. Andres.
So Andres,
so
where
what
are
is
you?
the ideal diameter? What is the ideal diameter, minimum and maximum, and depth for CFA piles? Also, what are the difficulties we face during insertion of reinforcement cage?
Thank you for the question. Well, the diameters are going to change depending on the equipment that you have. The typical diameters at that point in inches for North America end up being about, the minimum is about 12 inches that some folks have been installing, and they go typically all the way to 24 inches, about 600 millimeters. Going north from there, you need a sizable equipment to be able to achieve. We have been able to install in Keter up to 48 inches, so 1200 millimeter elements in that. But then you end up reaching is the depth of the capacity of the rig. So your drilling kit should be verified with the supplier to guarantee if it's going to have enough pull and torque to be able to drill that element. The difficulty installing the cages depends on the mix design. So if you have an appropriate mix design, fluid enough that is not losing the water when you're drilling into dry sands or similar, it should be able to have no issues. Concrete is more prone to difficulty cage going down. So a maximum depth in concrete has been around 30 meters, while the maximum depth in grout has been around 55 meters. So there's the two different conditions. On concrete, you normally will use a vibrator to vibrate the cage in, while in grout you will not need to.
I have one continuation question to that. Almost like it is related to quality control. So this question sent by Mr. Bimal C. Roy, so Next Case Limited. So he is asking how to understand if there is any discontinuity of concrete during pouring, how to check integrity, how to clarify that CFA gets better capacity than other board pile. So he has the three questions.
So a couple of answers to that. When you have a cage and you're able to pull up the cage and drop it into a hole, and the hole is able to go, the cage is going to be able to go down and install to the bottom, you are certifying already that the hole is open enough. The hole has to be completely open and continuous for the cage to actually be able to go through it. But when you're pumping the pile and pulling out, discontinuity on the pumping or too fast of a pull will result in a lack of material in that section. So all the computerized methods that the Bauer system, the Jan Lutz, the Keter system has at that point will allow to see if you have same pressure coming up, if you're losing pressure in that behalf, or if you're not getting volume. You may get the pump stroking with no material, and then on the screen you're going to see that no flow is going to that area. So you have to go back and re-drill those 2 meters or 5 meters and repump those meters in that. So with the computerized systems, it's pretty simple to verify if you end up having a continuous hole, as all the specifications for drilling and speed and volume has been verified and is being recorded in that degree. There was another question after that one.
The other one is continuity. He was asking continuity.
So
If there is
and so that's the point. If the pile is recorded and be able to show that you had continuous pressure, you didn't lose your pressure, and you were pulling on a consistent basis, and then your cage can go all the way down, it can be easily verified that is the case. There was another portion about higher friction capacity than the board piles, and that is in some specific soils you can end up getting a higher capacity friction when a board pile has to use polymers or bentonite to drill through rocks. The bentonite, the polymer, gets into the little crevices of that rock, and when you pour your concrete, you may get a mini sandwich between the concrete and the rock and the polymer in between, and that can minimize some friction and getting just end bearing. On the Orcas pile, because there's no use of bentonites or polymers, the grout will go and the concrete will go into the rock, creating that higher friction. So it's not in oil soils, it's in some specific soils it can create a better friction capacity.
Thank you. So here one question to Andres, once again for you. I'm not sure what is the typical price range for CFA installation costs per foot compared to a similar diameter and similar reinforced drill shaft? So Mr. Vijay.
It's a really tough question to answer because in every market is going to change the price of labor, the price of equipment, the price of materials. In our market and in specific conditions at that point, let's say for when the soils are appropriate for CFA, we have seen about a 30% improvement in the cost. So 70% cost of the typical board pile in the right soils and the right conditions. And it's not a one-to-one, because when you say it's similar element to similar element, it's not the same. At the end of the day, you want to see the whole duration of the construction, because some of the savings may not come by the cost of the element. The cost of the element may be the same, but if you can install more of the piles the same day, then savings are going to come in the time. So sometimes you may be having the same cost per element, but in the time you may save. In general, for our markets, sometimes have been in the order of 30%. Not in all markets. When we go to different areas of the country and the world, board piles outperform CFA when they have the right conditions.
Thank you. So here one question, maybe this question both maybe Andres as well as Franz Werner. So Mr. Balakumar from Simplex. So he is asking how to select the equipment. Is it based on soil profile, or is it based on selection of the tool or equipment as a whole? So he is asking like how to select a particular equipment for a particular application, means a soil type.
From my answer to that will be that when you're drilling soils, it's like when you're drilling in your house a wall and you have a hand drill, right? And so you cannot use a wood drill to drill metal. You can use a metal bit to drill wood, but it's not appropriate. So you have to have the right tooling on the bottom to have the right cutting capacity. If not, you're gonna not be using the best capacity of the tool of the equipment. There are some rules rules of thumb really in the market regarding depth and soils and friction that has to be done. But it does have to be tailored to the rig. Sometimes the difficulty of drilling is not the hardness of the soil, is that when you're drilling, the soil wants to hang on top of your auger, and so you need a lot of torque to rotate and a lot of pull more than crowd to drill down. In other cases, you have hard clays or rock, and you have to have a lot of torque and crowd to be able to just go into it. I'll relate the rest of the answer to Franz.
Just to add some comment on that. So in principle, you explained it very well. In addition, of course, the soil profile is very important, and especially when you look to the, let's say, depths you require for this particular pile, you need to understand whether you can achieve it with auger or just with the auger extension. And for instance, if you would require an auger extension, you need to ensure that stability of the soil is given. So that means if the stability of the soil is given, you can go for a smaller equipment. If the stability of the soil is not given, you may need a bigger equipment. Otherwise, you have a problem with installation. And as Andres said, it's not only about torque and pull-down force. It's very much also related about pull-back capacity, because usually, to be on the safe side, you should extract the auger without rotating or with just a very small rotation speed. So you need a certain retraction force, and therefore you need a good equipment.
I think it is clear. So here, Andres, one question for you. So Mr. Srinivas from Tata Projects. So he's asking, what is special properties of concrete, like workability, self-compaction for CFA piles when compared with BCIS piles, board cast in situ piles?
So there's it's not as much different in the sense of the self-compacting side of it, but the aggregate and the quality of the aggregate, if it is really rugged or is more rounded, and the fluidity of the mix is the really important aspect of it. More than anything, when you're putting a board pile, you have already installed your cage and you are trimming your concrete up, so you only need to fill the space and that's it. In our case, after filling the space, it has to stay fluid enough for the cage to be able to go down. So the water retention on the mix is critical to be able to get the final result. So you have to have a mix that stays fluid enough to be able to be pumped, not fluid too much that is going to segregate upon installation, because when you pump it, the last thing you need is a mix that stays too long fluid and then start to just get settlement and segregation on the mix. But more importantly is the water retention. In most some clays and sands, as soon as you pump your mix, it has a tendency by the weight of the same mix to push the water out of the mix, and the dryness of the materials also is going to suck the water, and when you lose humidity, it becomes too dense and the cage cannot go down. So the most important aspect is really that water retention condition plus the fluidity aspect of it.
Maybe one additional comment on that. For instance, one difference is definitely the aggregate size. So typically the aggregate size for the concrete which we use for CFA piling is much smaller, and the DFI CFA guideline for DFI India says, I think, 12.5 millimeter as the maximum. So this should also, let's say, ensure the pumpability. And so just have a look to the guideline, the Indian guideline. So, and you will see much more about this as well.
They are also on the large suppliers like BASF and many other suppliers of additives. They have really good mix designers that can help out, take a mix design and review it to see if they have the right products into the kind of, not only BASF, many of those suppliers, and they do it free of charge. Of course, they do want, of course, to increment their sales, but on the other hand, they can actually be able to verify if you have the right mix to be in that soil condition.
Yeah.
It is typical for us to request help from many of those guys when we're bidding large jobs to just make sure that the mix design is appropriate.
Here one question is there, Andres. I think this is a general, I think, a contracting point of view. So question asked by Minu. So I think general contractor terminology. Cost savings mentioned in the use of CFA piles over board piles. Does that consider additional materials and equipment cost for construction of CFA piles? Basically, I think intention of the question is that when we say optimization, so I think she is trying to ask whether it is material or material plus equipment cost or something. I could understand that material may not be very much, but time is the one which we are saving. Am I correct, Andres?
Time is one of the biggest savings in the picture, and because of time, you have to realize that every day you have to pay on a piece of equipment. So if that day you're installing one element or you're installing 4 elements, then the cost of the equipment was divided in 4 elements or divided in 1 element. So the time consideration is there. The raw savings also in many cases end up also coming in the sense of volume. Sometimes when you install a really large element to control settlement, your compression and tension capacity, you already achieve it way higher than you need for settlement, and then you need to drill more meters to get that settlement control. you don't need capacity. So you have a lot of volume used on the bottom section just for that settlement control. And when you have a smaller element, then in volume you use a little bit less material. Time is one of those things that are difficult to relate exactly to the cost, but you're correct. It's a lot to do with the speed of installation. The other conditions is when you have hard rocks or some difficult clays, when you're installing the casing, in many times you will lose your casing on the board piles, and you will have to just, if it was a temporary casing, you may lose the casing, and the cost of the casing start to add up pretty quickly. When we don't have the casing, we're taking that piece of the equation out of the picture.
So thank you, Andres. Here actually our Mr. Panwar, who is sitting with us, but he has some audio issues, but he sent us a message. So I think I can pass on this message to our audience. So he says, prospects of implementing CFA pile technology looks quite promising in India, and we as a consultant will always support the new initiation. The only thing we require is specialist contractor, skilled manpower and equipment. I think this is correct, and from his perspective. So Mr. Panwar, I think we got your message, and we will do that. So we are running out of time, already 10 minutes over. Thank you very much, Mr. Andres, Mr. Franch, Mr. Panwar, so for being with us almost more than an hour and giving a lot of inputs and a lot of insights, equipment point of view, owner's perspective, and real executional issues, and we have a lot of discussions. So this is really a great interaction. Thank you very much. And we have a few more questions from audience. I think we can reply to them separately, being the time is so tight now. Thank you very much.
Thank you. Thank you very much.
Okay.
Thank you, Mr. Madan Kumar. It was a great session. Lot of questions, lot of interaction, different viewpoints, and the best was that the motivation given by Mr. Panwar that CFA piles will be adopted in India. So we are all looking forward to adopting CFA piles, changing the industry, and educating everybody. So we need all support from the contractors and, as he has pointed out, the correct equipment. Thank you, Madan Kumar, for conducting this session and educating all of us on this aspect. Thank you very much.
Thank you, Kumar. Thank you.
Right.